Hi guys, it's your guy Olumide, and today we'll be solving another one of the most commonly asked tech interview question by top tech companies including Google, Amazon, Netflix, Meta, Microsoft, Apple, and other top tech companies. It's the margin communities problem, and the problem statement states that there are n people numbered from 0 to n minus 1, with each person initially belonging to a separate community. When two people from different communities meet and connect, their communities merge into a single community. So the goal now is to write two functions: connect, that is gonna connect person S with person Y and merge their communities by doing that, right? So, and meaning that it's gonna connect person X and person Y by merging their community. So person X initially belonged to a separate community, person Y belonged to a separate community. In fact, each person numbered from 0 to n minus 1 belongs to their own unique community. But when we try to connect X and Y through this function here, we are gonna merge them so they now refer to the same community. And then we have another function here, the get community size, which is going to return the size of the community which person S belongs to. So the get community size is going to be taken in a single variable, while the connect is going to be taken in two arguments, right? So person S and Y. So looking at this example, we are given n to be 5, and because of that we are going to be having 0 to 4. So it's going to represent person 0, person 1, person 2, person 3, and person 4, just like this problem statement highlighted here, that there are n people number from 0 to n minus 1, right? And now when we call the method connect 0, 1, it's going to connect two person 0 and 1, so that now 0 and 1 now belong to the same community. Now we also do the same for connecting 1 and 2. So because 0 and 1 are already of the same community, when we connect 1 and 2, or 0 and 2, they become the same community with 2. 0, 1 and 2 are now the same community. So when we perform get community size of 3, right, we pass in the person 3, the community size still remains 1, right, because it's actually just 1, it has never connected with anyone. But looking at this one, when we pass in 0 to the get community size, it returns 3 because person 0 now has 3. They are now in a community of 3 persons, right? Initially it was 1, then when we connect 0 and 1 together, the size of the community becomes 2. Why? Because both 0 and 1 are now of the same community. Now we connected 1 to 2 again, and now they are now 3 in number in the same community. So we also perform this connect out right here, where we connect 3 and 4 together. So, and in doing that, we should be having 3 and 4 connected together like this. So, and then when we perform the get community size on them, it gives us community size of 0, it gives us 3. Fine, sorry, let's try to check for community size of 4. It's gonna give us something like 2, right? Because fine, it was 1 at first, but because we connected 3 and 4, now the community size becomes 2. And this is just the output right here, whereby we perform a connect on 0 and 1, 1 and 2, then we try to get community size of 3, which will return 1 at first because we've not connected it to 4. So we now try to get community size of 0, but because we've connected 0 to 1 and 1 to 2, so that return 3 that you can see here. And now we now connect 3 and 4 together. So when we try to check the community size of 4, it returns 2 that we can see right here. In this problem, we have n people having their own community, and we will want to merge, or let me say connect two people, and by connecting them we are going to be merging their community, right? And also we want to be able to determine the size of the community of any particular person before and or after merging at any point in time. So, and this will lead us to the union find method. So it's a data structure actually. So it does two things. First of all, it takes two elements from different sets and make them part of the same set. So it unites them, and then it determines what set an element belongs to. So And we see that this really cater for the need of this problem that involve connecting two different people of different community, so that they now merge and become the same community in place. It's not as if they got added to a new community, they merge and then become in the same exact community. So I also want to be able to find which particular community a particular person belongs to, and then the size of that community. So let's consider n input that is given to us as 5. Don't forget that n will represent the actual number of people starting from 0 to n minus 1, meaning that if we are giving n to be 5, we are going to start from 0 to 4. So now let's say that 2 of these n people, person 0 and person 1, are actually belonging to a community or a set, and then person 2, 3 and 4, which are the remaining 3 people, now belong to another set, that is another community. So you see that to merge any of these two communities, we will need a representative, in fact, to identify that okay, person 0 and person 1 belongs to the same community. Then there should be something that is common to both of them, right? Meaning that what we will need the representative. So we can say that right here is supposed to be person 1. Sorry about that. So now we can say that okay, let's person 0 be the representative for this particular community, so that any person that is in this community, we have the representative have person 0, and definitely we can know that person 0 is representative for this particular set of people. Now similarly, we can have person 2 to be the representative of this other community. So in code, this can be reflected through an array. We can have a parent array whereby each person in that array, it is actually 0 in there. So you can say that person 0 we have a parent 0. So in this case now, person 0 will have a parent 0, person 1 will also have its own parent, right, which is 0, and then person 2. So we can use it as a parent array, right? So but this particular one will be explained later. I mean, we are gonna talk and discuss more about it later. For now, let's discuss how the union works, and we'll go back to how the parenting works. So for the union, let's consider the previous example whereby we have 5 people from person 0 to person 4, right? So now let's say we want to connect person 1 and person 4 together. So the first thing is that we will need the representative of each of these person, so that we can know what community they belong to, and what community we are trying to merge together. So and then we are going to be using a find function or a find method, and we are going to discuss more on that later of how the find function is going to behave. But this find function is going to get us the representative of the person 1 and person 4. Now we have the representative as 0 and 2. Now we need to choose one out of this representative, so it can be the representative of the merged communities, right? So let's say we pick representative 0, the person 0 now, which is the representative of this first community. So let's make it the representative of the merged community. So this means that we'll be merging all the person in the second community to the first to this representative, so that now they now belong to a union. We are now united to a particular community that has this representative 0, and this will means updating the parents of each of the person that are in the second community. It will mean updating their parents to become node 0, right? For more efficiency, we can, instead of having to imagine a situation whereby the people that are in the second community are much more larger than this. Then it's gonna involve us changing each of this person, their parents, to become this new representative of the merged community. So, and a more efficient way to do it instead of doing that is just by changing the parents, updating the parent of the representative of the second community, updating his parents to be this particular one, which is the representative of the first community. So that way now all the children and all the persons that are in the second community will indirectly have their representative to be the one that is actually the parent of their initial representative, meaning that since this initial representative of the second community now have its parent, meaning that now have its representative to be repo S, definitely indirectly all its person, all the person in the second community will indirectly have their representative to be rep S, which is the representative of the first community. If rep S and rep Y actually have the same representative, so let's say we are trying to connect 3 and 4 together just earlier before we merge them. Let's say in this case we are trying to connect 3 and 4 together. Since 3 and 4 already have their representative as 2, so we don't need to do anything or merge any one of them because they belong to the same community and they have the same representative. Now let's talk about the find function. So the find function that I told you we are going to talk about later, what it does is that it's going to return the representative of the community that a particular person is. So if we are trying to find one, it means that we need the representative of the community that one is. So and then looking at this visual now, we see that the representative is 0. So even if we are trying to find 0, the representative of 0 is still 0. Why? Because 0 is a person in this community now, and the representative of this community is 0 itself. So similarly in this other community here, if we are trying to find representative of 4, it is 2. So and similarly representative of 3. So for any person in this community, they have the same similar representative. So but now we need to know the difference between a representative and a parent, right? Actually a representative is the person who represents a community, and while a parent of a person is the node that person is pointing to, right? So meaning that if you look at it right here, we can also say that 2 is actually a parent of 4, right? And also we can say that 3 is a parent, 2 is the parent of 3. So now, but it takes more for 2 to be the representative of 3, or the representative of all this community. So a parent is actually the person that a particular person is pointing to, but representative has to do more, has to do with being it has to do with a person that represents the community, meaning that a person that it is the parent of itself, right? So look at this now. The parent of 0 is 1 actually, but its representative is 2. So meaning that it corresponds to the root node of the community. So the one that after it there is no other person, so it is the head person. So now let's talk about what the find function actually look like. So this is what it looks like, the find function. So first of all, it's going to be a recursive function, right? Why? Because we are not really looking for the parents, so we're not looking for the direct parent, we are actually looking for the representative. So even when we find out the parent, we still have to go on deeper to look for the parent for the parent until we get to one that keep giving us the same value even when we are finding its parent. So that is one that it is the same as its parent. So if S is equals to parent of S, that is don't forget I talked about using the parent array to keep track of the parent of each of these person in the community. So don't forget that each person is represented as some sort of array. So if we have n people, maybe 5, so that means we're having person 0, 1, 2, 3, 4. So definitely we can have an array of 5 elements. So each of these elements now will represent the parent of that particular person. So if n is equals to 5, right? So we can have our parent array to be equals to parent to be equals to an array of probably 1, 2, 3, 4. And what this just means is that this particular index 0 this value 1 corresponds to the parent of the index 0, and this value 2 corresponds to parent of index 1, and this corresponds to parent of index 2, and this corresponds to parent of index 3, and then we have this to correspond to parent of index 4. Why? Because in a situation whereby n is equals to 5, we are going to be having number 1, we're going to be having 5 person, right? Although it's going to be number from 0 to 4. So, and this is simply what this means. So that's the parent of a particular person that we're trying to find. Don't forget that in the find function we're going to be passing in a person. So, and what we want to do is that I want to find the representative of the group that person is in. So for a particular person, it can have a parent 2. It can have a parent 2, but that doesn't mean that is the representative. Just like in this case whereby this particular person 0, we have a parent 1, but that doesn't mean that that parent is the representative of the community. So if so, this is how the code goes. If s is equals to parent of s, that is, if that particular person is the parent of itself, if it is actually the last parent you can ever have, then we want to return s. So otherwise we just keep finding parent of s, meaning that we find parent of what we do is that we find parent of 1. Imagine if we're trying to find the representative of the community that 1 is in. We find parent of 1 is going to give us 2, right? So then we find parent of 2, we find parent of 3, until we get to where 1 whereby it is the parent of itself. So in a situation like that, 0 1 2 3 4, 1 whereby it is the parent of itself. So otherwise we keep traversing. So that's how we work on that. You will get to understand more better when we start code implementation. Now let's talk about how we unite and connect two person from different community. Fine, we talked about it the last time. Now we want to expand more on it. So the last time we talked about how to identify the representative of each of these community, and we decide to choose one. And in the last example we choose 0, so we merge the other one, which is this right here. So we try to merge all of the other one in this second representative to 0, and we later talk about an optimization whereby we don't really need to merge all of them like that. We can just change the representative of the parents of the representative of the second community. You can just set it to be the representative of the first community, so that way each and every child or each and every parent person in the second community is now indirectly having their representative to be the first community, because earlier on this particular parent and this particular representative 2 of this second community, it is the representative of the second community. So it is the parent of itself, meaning that when we are trying to do parent of 2, actually gives us back 2, but now we are trying to set it to the representative, so that it now have a senior, it now have a representative which is now 1, so that way all of them are connected to which is now 0, and that way all of them are connected to 0, right? So now to establish more on that, we say that in a situation whereby we pick this 0, consider this example now, right? In a situation whereby we pick this 0 to be the representative, we are trying to merge let's say we are trying to merge these two communities together. Now when we pick 0, this is what we have 6 and 7 coming closer, and then having 6 having its representative to be 0, right? So and then the distance from 7 to its representative is now +1. Fine, because before 7 have its representative to be 6, but now because we merge them, 7 have its representative to be 0, so it has to go. Don't forget I talk about the find function that will help a particular person find the representative of their community, and because this community have been merged, so the new representative is 0, right? So it's no more 6 for this particular person 7, and because of that you have to first find this is now the parent. 6 is now a parent, not a representative, so it has to go further and further until we get to 0, right? So this means that a distance of +1. Similarly, if we choose y now, I mean in this case now, if we choose y, we have all of these things attaching themselves to 6, right? So in the sense that look at this 6 now, which represent the head, the representative of the second community. If we merge the first community with it now, we see that all of them comes here, just like how it happens for this. So but now you see that now, because the first community have a larger number, larger people, so you see that each of these people will have their distance increased by 1, and because of that, for optimization, it suggests that we should go for a representative. If we are trying to merge two representatives, right, we should go for the representative that have a larger number, meaning that representative X now for this particular community have a larger number, right, and because of that we should merge, we should bring this one to merge it, meaning that we should bring this fewer representative, fewer community, or this community of fewer people to merge up, so that there will be less people that will have their distance to their representative increased by 1. I hope you understand this. So because for this case now, whereby we come and merge, we merge X with Y, so that like you can see in this version, so that all of X come and merge it with this Y. Each value 1, 2, each person 1, 2, 3, 4, 5 now have their distance to their representative increased by 1. Initially it's just here, their representative is just 0, but now this 0 is now a parent. Their real representative after being merged is 6. So it means that anytime when I get the representative of 5 or 4, or I'm trying to find the representative, it takes one more distance. So imagine if we have millions of people in that community, so it's just gonna take more time. So but instead of doing that, we are going to go for the person with smaller smaller community, just like this second community rep Y. So because it has smaller, it means that at least less people will have their distance to their representative increased by 1, which is only 7 in this case. So and because of that, that's just a simple optimization technique, and this is how we are going to be writing the union function. So first of all, when we're trying to connect, that's the same as union, right? X and Y, person X and Y will first of all go on to find their representative for X and Y, which we are gonna use the find function. The find function is going to be like a recursive function, so it's gonna take in S, try to get his parent, try to get that parent's parent until it gets to the representative. So and the representative is a parent of itself. So when it gets to a particular value S, such that, or a particular person S, such that parent of that person is that person itself, definitely we've gotten to the representative for that community. So we find that for X and we find that for Y as well, right? So and then we're gonna collect it as rep S and rep Y. So now we wanna first of all make sure that rep S is not equals to rep Y, meaning that both S and Y are not of the same community, that is, they don't have the same representative. If they do not have, if they do, we are not gonna do anything. So because it means that they have the same community, so we don't need to merge them anymore. So but if they are not of the same community, that is, if they have different representative, definitely we wanna go get the size of representative of S, they want to get the size of representative of Y. And what this is trying to say is that we are gonna be needing an array, so that is gonna keep track of the size of each of these person. So I mean the size of each of these representatives. So it's gonna try to check which of them have a higher size. So if the size of the representative of S is greater than that of Y, all of these things are still gonna look at in terms of real code, and you're gonna understand it more clearly. So if representative of S have much size than Y, then what we're gonna do is that we're gonna change the parent of this representative Y. We're gonna set it to representative S, meaning that instead of representative Y being a parent of itself, meaning that it is the representative of that community, is now gonna have a new parent, which is representative S. So meaning that it is the second community that is going to meet the first community, because the first community have a higher population than the second one. So and similarly, to get things updated, we are gonna set the size of representative S, we are gonna add it with the size of representative Y, so that we can now because now is a merged community, so representative S we now have more size by adding Y to join it. But in a situation whereby their size are equal, or representative y have higher size than s, we're gonna do the reverse by setting the parent of representative s to be representative y, and we're gonna increase their sizes. So, and then we see that this method of having a size array will also help us to in solving for the second method. Don't forget that in the problem statement we are given two methods. So we have the get community size, whereby we will pass in a person and we expect to get the size of the community of that person, right? So, and then with the help of the size array that we talked about, that we're going to be creating, is going to help us to get this problem easily, because what it's going to do is that it's going to find s. Find s means that it's going to go and find the representative of that person s. After finding the representative, then it's going to return the size of that representative, so that way we can get the community size easily. So another optimization we can do in solving this problem is path compression. So really, if we are trying to find, imagine we have the path, we have a particular community like this, so whereby we have this person 3 and person 6 having a parent of person 2, person 6 having a parent of person 5, person 2 having person 6 having a parent of person 5, also person 2 having a parent of person 1, and person 1 having a parent of person 0. So what I'm trying to do in essence right here is that here you can see that they have parent just before the representative, right? So when we try to find 3, that is, we are trying to find the representative of person 3, right? So what it does is that, we end up finding the parent of person 3, right? So, and the parent of person 3 is person 2, right? So, but we are not just gonna end there. That's what our find function does. It does not end it unless it gets to a particular person whereby it is the parent of itself. So it go back up again to find the parent of person 2 and find the parent of person 1 until you get to person 0, right? So similar thing apply to person 6. In finding it is go find the parent and the parent and parent until you get to a person whereby it is the parent of itself. So you will understand what I mean by this in the code implementation. So it's just simply that we are gonna have a parent array, and this parent array we are gonna initially set it's gonna be an array of it's gonna be just an array of 0, 1, 2, 3, 4. So let's say we have 5 people, so it's gonna be from 0 to 4. So this is how the parent array is gonna be initially, so that we can know that the parent of person 0 is person 0, because they actually initially belong to their own unique community. So parent of person 1 is person 1. So as we are merging them together, imagine we merge 0 and 1, so parent of person 1 will become parent of person 0 will become person 1, right? So we just keep updating it on and on. So if I wanna find the, because similarly, if we try to connect person 1 and person 2, the parent of person 1 becomes person 2. So, and when we are trying to find the representative now, let's say we want to find the representative of person 1 after all these changes, so it's gonna give us person 2, right? So we are just gonna proceed to find the representative of person 2. It's gonna give us the same person 2, and simply like that we already know that person 2 is the parent of itself, so therefore it is a community on its own. Whereas because we have not joined person 3 with anything, the parent of person 3 still remain person 3 and the size still remain 1. So we are just going to be having to array the parent array and the size array. So this is just how it's going to be, and that's what I'm trying to say here. So you just keep looping up. Whenever I want to find parent of person 3, it keep going to its parent until you get to one whereby it's no more changing. Definitely that is a parent, that is the representative. So but imagine now in the process of returning, find is gonna definitely return the representative, which is the person. So in the process of returning that particular person, because we keep on calling that function, recalling that function up to this point, it's first gonna return it to it's gonna return that representative, say 0. It's gonna return it to this particular to this particular person. There's gonna return to this particular person. There's gonna return why? Because we call the function recursively to this person's parents. I mean to person 3's parent. Then we call it to person which is person 2, right? Then we call it to person 2's parent. So it's gonna be returning back like that in that manner. So meaning that even though we just need it for person 3, it's gonna call it for all its parents until you get to that particular representative. And we can actually make utilize that so that we can so in that way we can use it to reduce the distance of a particular node to its representative. Why? Because we can just easily set all of them. So when it returns 0 to this person 1, imagine this person 1, which is parent, we can just set the representative of person 1 by saying that parent of 1. So because it has returned 0, we are gonna set it to 0, so that next time it will know that it is 0. So and then when it becomes when you send it that same 0 back to person 2, we're gonna say parent of person 2. Instead of setting to person 1, we're gonna set it to person 0. Similar thing applies to person 3. So we're gonna set its parent to 0 instead of 2, right? So that way now all of them will now be directly connected to person 0. And now we can do it is this: in our find function, we're just gonna update it in such a way that find if s is equals to parent of s, meaning that if it has gotten to that representative, return s. So it's gonna return s. It's gonna keep returning s, and what we want to do is that we want, instead of just returning the representative and forgetting about it, another call to it, we make it to go and do it all over again. Instead of doing that, we just set that particular return value so to the parent, right? What I'm trying to say in essence is that we're gonna say find parent of s. Here it's supposed to be this. So the return parent of s, right, that is called, the find parent of s that is called here will not just be returned, it will be saved as the new parent. So since we've gotten the representative as 0, as it's returning it back to all of each of these parent node up to the child parent, right, up to the child person, I mean the very last person here, we're gonna be collecting that value and be setting it so that all of them now will be pointing at 0. So mean that we are updating. So initially the parent of this node 3 is node 2, and the parent of node 2 is node 1 but now what we're gonna do is that we're gonna set the parent of all of them to 0, 0, 0, and that's what it means by this parent of s equals to. So it's gonna return 0 eventually. I'm gonna be setting it to 0, and after setting it, we're just gonna return that 0. So all of them will be directly connected to their representative. So this is how we solve this problem. Let's go into the code implementation so you have a better understanding and grasp of what I've been talking about. Now let's go into the code implementation for the margin communities problem. So we are going to be defining the union class. So you can call it the union find. So you can also call it the margin communities class. So you can call it any names actually, but I'm just trying to implement that union find structure, that data structure, whereby it will have the method union and method find, so that it can help us to connect to communities and get the size of community. So in the initialization, okay, let's first parse and paste in some things. So here I try to paste in the number of people having a unique community, so n equals to 5, right? So and then I try to call margin communities on n, so that I can create an instance of that class, and then I can call the method connect and to connect 0 and 1 and connect 1 and 2. So just like it is in the code implementation. So I'm just when I pass in n equals to 5, it's gonna create 5 people 0, 1, 2, 3, 4, right? And then I'm gonna try to connect person 0 and person 1, then person 1 and person 2. So I'm not trying to print the I try to print the community size of person 0, which is gonna be 3, right? Because we have connected 0, 1 and 2 together. So okay, let's define initialization function init. So this init is gonna take in n, which means the people of the community, I mean the total people. So let's define the I think we called it the parent, right? Parent array. So this parent array, you will see that it's gonna be a dictionary, right? So let's make it a dictionary for easy access. So I'm gonna make it a dictionary of I to I for I in range of 5. And then you might be wondering that why are we doing this? So the reason why is because first of all, this n equals to 5 actually means 4 people, right? 5 people, 0, 1, 2, 3, 4, 5, as it is given in the problem statement. If you check the problem statement, you will find out that they say that this, like, now let me check it quickly. So it says here that there are n people number from 0 to n minus 1. So whenever we're giving the n as any value, it means 0 to n minus 1. So now and then don't forget that these people, they initially have their own community, and they are the only single person in their own community, right? So meaning that they have their own unique, they're not yet merged initially. So because of that, when we are trying to find the parent of any value, what I'm trying to say is that if we are trying to find the parent of person 0 or representative of person 0, it is itself. So that's why I say that I ratio I. So 0 ratio 0, 1 ratio 1. So it's gonna be a dictionary of something like that, right? So I think there's an error here. Okay, so it's gonna be like that. So similarly, self dot let's say the size array. Now the size array will be an array of array of 1 for I in range of n, right? Okay, sorry, this is supposed to be n. So why we are doing this for the size also is because initially the size of each community of person is just 1. So after doing that, now let's move on to create the connect method. So connect is gonna take in self, and then it's gonna take in two individuals or 2 person, X and Y. So I want to connect and merge into a single community. So it's gonna return none. So we just wanna connect them. So, and this is how we do it. We're gonna find their representative first using rep of S comma rep of Y. So to be find, so we're gonna define a method also. We're gonna call it find method that is gonna find the representative of both F, S and Y. So just like I explained in the logic. So but we're gonna define it. We're gonna see how define the find method. So it's gonna go find their representative. Now if the representative is the same, definitely the both S and Y are in the same community, and in a situation like that, we don't want to do anything. So if rep of S is not equals to rep of Y, I mean that in a situation whereby rep of S is not equals to rep of Y, then we want to do something. So in that case, what we want to do is that we want to try to check which one of them have the biggest size. If size, don't forget that initially their size is 1. So if size of rep of X is greater than rep of Y, so in case if their size, probably we've merged one with another one, and now the size of rep of S is greater than size of rep of Y. So I can do that by saying self dot size of this and self dot size of rep of Y. So this way is gonna return the size of each of this this community that have this particular representative as rep of S and rep of Y. So if the size of rep of S is greater than that of rep of Y, what we want to do is that we want to merge the Y with S. So it is going to be like Y coming to SY because rep Y have a lesser size, right? So how we do that is saying self dot parent, so of rep of Y is equals to rep of S. So this way we have set the parent of rep of Y to rep of S. So don't forget that initially they are parent of themselves. Now rep of Y is now a parent of rep of rep of S is now a parent of rep of Y, meaning that they are merged. It has merged with rep of Y. So and what I want to do is I want to update the size. So self dot size So why? Because rep of x now have more size because it has merged up with rep of y. So but in a situation whereby it's not like that, rather it is rep of y that have a more greater size than rep of s, or better still, they have the same size. So then we just be doing the same thing, but we are gonna be merging s to y. So this piece is gonna be s, y this is gonna be y, meaning that we are gonna set the parent of s to y because y have a higher size, or probably because their size are the same. So we are gonna set this to s so that it could update the size. So, and that's what we are just doing there. So now let's define the get community size. The get community size now to get the community size. So it's gonna take in a particular person in order to get its community size, right? So and what we're gonna do is that it's gonna return an integer number, right? And what we're gonna do here is return self dot size. We want to get the size of the representative of that particular person. So self dot parent self dot find, sorry. So self dot find is gonna go find the representative of that particular s. So I hope you understand what we just did there. We are gonna define a find method. That find method is gonna get the representative, right? So just like we use it right here, so it's gonna get the representative of that particular person, and from the representative we can easily get its size through the size array that we defined up here. So now let's proceed to define the find method. Find method is gonna take in self as well. So I'm gonna take in a particular person that I want to find the size of. So I'm gonna return an integer. So it's gonna return the representative. So it's represented as an integer too, right? So why? Because all this person are actually represented as an integer. So when we pass in n equals to 5, it means 0 to n minus 1 person. So and what we want to do is that it's going to be a recursive function. So but until when we get to a point whereby s is equals to the self dot parent of s, definitely we just want to return s. That s is the parent that we're looking for, is actually the representative because it is the parent of itself. So there's no way of getting to any other person from it. So otherwise, first of all, we want to, don't forget the optimization technique. Like I said, that you should update at each point, update it. So whenever it returns that representative, so we're gonna just update it as the parent of that particular person. So self dot parent of s equals to self dot find self dot parent of s, and then we just return self dot parent of s. So and what this does is that instead of having to return the representative after getting it, instead of just returning s, we actually want to update that the parent at each point. Each of the parents or let me say each of the person, we want to update their representative to be that value. So that's simply what we are doing. So now let's run this program and see how it goes. I run the function and it gives me 2, but it's actually supposed to be 3, but the answer is 2. That it gives me 2 right here. So right here. So when I look at what can cause the problem, I found out that is a minor issue right here, whereby we are, after setting the parent of each of this representative to the other one so that we can merge them efficiently, we try to update the size, but actually we need to find the size of both rep s and rep y. So and take this size and sum it up, right? So meaning that fine, okay, because we merge x with y, because we merge s with y, it's supposed to be self dot size of rep y, right? So not just rep y, we are not adding that value in that person to it, we are actually adding the size. So but I made the mistake of just doing self the size of rep y equals to rep s. So instead of self the size of rep y equals to self the size of rep y, so it's the size that they are merging together. So if I run the code now, it's gonna give me a 3. So and this is it right here. So I really do hope you understand this problem. This is how to go about solving it. Thank you. Do well to subscribe to my YouTube channel, please, guys. Thank you.